Bismillahirrahmanirrahim. In this video, I'm going to talk about the derivative of tan and cota. The derivative of tan p px, the derivative of tan u. The u is function of x, equal to. So the derivative of tan equal to secant squared u of x times the derivative of u times the derivative of u. So now example. We have y equal to tan 5x. So then the dy dx y prime equal to the derivative of tan is secant squared u, secant squared 5x times the derivative of multiplied by 5x, the derivative of 5x. So the derivative of 5x is 5. Is what? Don't multiply this by this one. It's a big mistake. Don't write 25x. So we have to write 5 before secant. So is equal to 5 secant squared 5x. Secant squared 5x. Another example. Example 2. This is example 1. Example 2 here. Y equal to tan 8x squared. So now the angle is 8x squared. So the derivative is the derivative of tan y equal to the derivative of tan is secant squared 8x times the derivative of 8x squared. So tan secant squared 8x squared. So the derivative of 8x squared tan u secant squared u. So the derivative of 8x squared is 16x. So again, we have to write first 16x and then secant squared of 8x squared. 8x squared. Again now, tan u secant squared u. Tan u, this is the u. Secant squared u. Multiply by the derivative of 8x squared. So we have to write 16 before secant, 16x. Okay, another example. Y equal to, if we said another example, y equal to tan cubed 8x. How to find the derivative? Now what I have like u to the power n. What is the u? You know, it is tan to the power n. So the derivative is n u n minus 1 times the derivative of u, the derivative of tan, because this one means I have here tan 8x tan cube mean all to the power 3. So this like the u here, which is tan, and n is a 3. So now the derivative is the dy dx y prime equal to 3 times 1 would be 3 and tan 3 minus 1 is 2. So be tan 8x. So 3 and minus 1, 2 tan squared 8x times the derivative of tan now, like the derivative inside the bracket parenthesis. The derivative of tan is secant squared 8x times the derivative of tan. Secant squared by multiply the derivative of the angle 8x is 8. Now that 3 minus 1, 2 tan squared, but the derivative of tan is secant squared, the derivative of the angle 8x is 8. So 8 times 3 So 8 multiplied by 3 is 24. 24 tan squared 8x secant squared 8x. So this is the derivative. Another example. If we said y equal tan 4x squared plus 7x. Now, tan u, the derivative of tan u, the y prime, the tan is secant squared u. So this represents u, tan u. So secant squared u, secant squared for x squared plus 7x. Tan u, secant squared u, times the derivative of the u. What the u is? This the u for x. So the derivative of this one, 8x plus 7. 8x plus 7. So the derivative is 8x plus 7. Again, we have to write this one before secant square. So the answer is 8x plus 7 multiplied by secant squared for x squared plus 7x. So this is the answer. Okay, another example. Write it here down. Another example. See, if we said example y equal to tan, let us say this one is the 3x plus 5 to the power 4. So how to find the derivative? Now this one is not tan power 4. This is not tan power 4. This one tan only one tan power 1. But the angle is 3x plus 5 to the power 4. So now the derivative is the derivative of this one equal to. Now the derivative of tan u dy dx equal to. The derivative of tan is secant squared the angle. The angle is 3x plus 5 to the power 4. Now, what is the derivative of this angle? The derivative of the angle is, we have 4, like we have now u to the power n. So the derivative is equal n, and u to the power n minus 1 times u prime. So if you have u to the power n, will be n, and multiplied by u to the power n minus 1, the power is n minus 1, times u prime. See now, let us use this one here. So the derivative of this one will be times, what times 3, the derivative will be here 4, multiplied by, I have here 3x plus 5 to the power 4 minus 1 is 3. So you have u to the power n, u to the power n minus 1, the derivative of what? The derivative of 3x plus 5. The derivative of 3x plus 5 is 3. So multiply by 3. So now this represents the derivative of the angle. Again, tan u secant squared u. But then times the derivative u. What is the u? We have the derivative, we have 3x plus 5 to the power 4. So the derivative is 4n. Then u to the power n minus 1 will be 3 times the derivative of 3x plus 5 is 3. 3x. Now, so we have to write it in this way. 3 times 4 is 12 multiplication, and this will be before secant square. 3x plus 5 to the power 3 times secant squared 3x plus 5 to the power 4. Another example. Okay, another example right here. Example. If the question have y equal to 20 tan 6x, so what is the derivative? So the y prime, the dy dx, is equal to 20. The derivative of tan is secant squared u. The u is 6x. This is the u. 6x, secant squared u, 6x, times the derivative of u, where the derivative of 6x is 6 multiplied by 6. Now this one is equal to the answer. 6 by 20 is 120. Secant squared 6x. This is the answer. But see, students, if I have not 20, I have example. If I said y equal to 20 x cubed, or x squared or x cubed, okay, this one is x cubed, x cubed here, say this one, 20x cubed multiplied by tan, let us say 5x. How to find the derivative? Now this one, we have to use a product rule. Why? Because I have this function of x, not like this one at 20. Now what I have 20x cubed. So x, now then to find the derivative, we have to say 20x cubed is represented as the u, and this one is represented v. So you have to use u v prime, you have to use the rule u times v prime plus v u prime, product rule. Product is the first, this is the second. Now see, to find the derivative of this one, let's have to rewrite it. The question is 20x cubed times tan 5x. Now the derivative is the y prime. See, the y prime equal to dy dx, or y prime. The first one is this. We said this is the first one. This is the first. This is the u. So now the rule is the first one. The first is 20 x cubed, is the first, multiply by the derivative of the second, this is the second. The second is tan 5x. So the derivative of tan is secant squared, secant squared 5x times the derivative of 5x is 5, plus, see the rule, plus what the second one is, this is the second one now, tan 5x. So the second tan 5x times multiply the derivative of the first one. The first one is 20x cubed, this one. So the derivative is 60x squared. So the derivative of this one is 60x squared. Be careful. Don't multiply 5 with 5x. 5 multiplied by this one, multiplication. Okay, not the angle. So it will be this one, 5 by 20. So the answer is 100x cubed secant squared 5x plus 60 x squared. So number first x, and then tan 5x. Don't multiply 60 by 5x. It's a big mistake. 60 times tan, 6x times tan. Now this is the derivative of the tan. What about now the derivative of cotan? So the derivative of cotan dx, if I have cotan u, the derivative of the cotan is equal to minus cosecant squared u times the derivative of u. Example, y equal to, in this example, y equal to cotan 7x. So the y prime dy dx is cotan is minus cosecant squared 7x times the derivative of the angle. What is the angle? Is 7x, 7. So times 7. Again, don't multiply this big mistake. So 7 should be before cosecant. So the answer is minus 7 cosecant squared 7x. Another example. Let's here another example. Let's say example y equal to 20 cotan 4x squared. So the derivative, the dy dx. So the derivative dy dx is equal to, now cotan, there's only one cotan to borrow on, but the squared is x for x squared the angle. This one for x squared the angle. So the cotan is 1. Now the derivative of cotan is minus, I have 20 minus 20 cosecant squared, What the cosecant squared? Cosecant squared for x squared. So cotan is minus cosecant squared. Multiply the derivative of the angle is 8x. Now 8x multiplied by 20 minus 20 minus 160x cosecant squared. The angle is 4x squared. That is 4x squared. Okay, another example. Example. If we said y equal to, I have here 100 multiplied by cotan, 4x squared plus 2x. So the dy dx equal to dy dx equal to 100. I have this one, okay, 100. And the derivative of cotangent is minus cosecant squared, because the angle is 4x squared plus 2x. Okay, multiply by, now the cotangent is minus cosecant. The derivative of the angle is, equal to what? 8x plus 2, 8x plus 2. So now this we can write it as, so I have here minus 100, so I have negative 100 multiplied by 8x plus 2, and then what we have? We have cosecant squared. Cosecant squared, the angle is 4x squared plus 2x. Again now, 100 cotangent, the derivative of the cotangent is minus cosecant squared u times the derivative of the angle, the u is 8x plus 2. Then I have multiplied by minus by 100. This can be multiplied by negative 100, or even can take 2 out, will be equivalent. So I can multiply negative 100, 8x plus negative 100, 200, or we can take 2 out. Then this, you can write it here, 2 out. I can write it, if I take 2 out, it will be minus 200, and this will be 4x plus 1 cosecant squared for x squared plus 2x. I can write it in this way. Also, I can write it in this way. Okay, now if we have now example, see, if I have here y equal to, let me to say, for example, tan 3x over, for example, cotan, for example, 5x. Now what I have to use here, I have to use quotient rule. So you have u over v prime, will be this one, v squared, v times the u prime here, derivative of the numerator, minus what? Minus numerator multiplied by the derivative of denominator. So the dy dx, is equal to the angle, not the same angle, cannot be simplified, not the same angle, so I have to use the quotient rule. The quotient rule is, now quotient rule I have here, cotan 5x all squared, or I write it here, cotan squared 5x. Then this one v squared. So then I have here v cotan 5x times the derivative of tan. What the derivative of tan is? Secant squared u times the derivative of the angle is 3. That was the angle 3 minus. Now minus the minus is the rule. Now we said v u prime, u times v prime. U times v. What is the v? The v is cotan. Now I have then u. I have this is u. This is v. V squared. V times u prime minus u. The u is tan 3x multiplied by. Now the derivative of denominator. Denominator is minus the derivative of cotan. The derivative of cotan denominator minus cosecant squared. So minus cosecant squared u times the derivative of the angle. This is the angle 5x. So the angle, because minus cosecant squared u times the derivative of the 5x is 5. Now it can be simplified. This one is equal to. I have the 3 first. I have to write the 3 first. And here I have to write cotan 5x secant squared 3x. And I have here negative 5, and here negative will be plus 5 tan 3x. This one tan 3x cosecant squared 5x over what? Over cotan squared. This is not clear. Let's write it here in this way. This is one cotan squared 5x. Okay, so this is the answer. Can be simplified, but so this is here. Again, tan u over the numerator and denominator. Denominator squared, and they have denominator multiply the derivative of numerator. So this is the numerator. This one is the numerator. Okay, this one numerator. So this is the numerator, and this one the denominator. So the rule is denominator square, denominator multiply the derivative of numerator. The derivative of tan is secant squared u multiplied by the derivative of the angle 3. The x is minus. Then minus denominator now, this one. So minus what? Minus numerator 10px multiplied by the derivative of denominator. Derivative of cot u is minus cosec square u times the derivative of 5x is 5. So then I have here negative 5, or negative will be positive 5. 10px cosec square, and this one 3, that I write it before. See, and if in case if we have multiplication, can use the multiplication rule. For example, if I said y is equal, for example, 5x squared cotan 4x, so here I use the product rule. The product rule u v prime is equal to u times v prime plus v times u prime. So now in this one, to find the derivative, the dy dx is equal to this is the first, this is the u, and this is the second, because multiplication now. So now the multiplication of this one, I have the first one, 5x squared, the derivative of cotan is minus, the derivative of cotan is minus cosecant squared the angle 4x, multiply the derivative of 4x, it's equal to 4. Then a plus the second one is cotan 4x, is the second one now, is the second one. Okay, multiply by the derivative of the first one. The first one is 5x squared is 10x. 10x. So the derivative of the first one is 10x. Okay, 10x. Now, I'm using here, I use the product, using the product rule. Okay, so again, the first one, this is the first one. The derivative of the cotan is minus cosec squared 4x by 4, and then plus the second one, cotan 4x, the second one, multiply the derivative of the first one, 10x. That was the first one, 10x. This one also can be simplified. Okay, this is a plus here between. So this can be simplified. So it's equal to minus, I carry it in this way, minus this one 4 by minus by 20, minus 20x squared and cosecant squared 4x, and this one 10x plus 10x cotan 4x. Because 10x should be before cotan, and 4 minus 5 should be before cosecant, and x could be for also cosecant. So this is the answer. But here, if you look at this example, if I change this example in this way, and if I write y is equal to 5x squared plus cotan 4x, now the derivative is 1 by 1. So the first one is the derivative, now the derivative will be here. The first one, 5x squared, will be only 10x, only the 10x, the first one. Then a plus, the derivative of cotan is minus cosecant squared 4x times the derivative of 4x is 4. So then that is mean the answer is equal to, I have 10x, 4 by minus and positive, minus 4 cosecant squared 4x. Look at the difference. Here what you have 5x squared times, so I have to use the product rule first by the derivative of the second plus the second cotan, the derivative of the first 10x. But this one we have a plus 5x squared plus what the plus cotan. So the derivative of the first one, just 10x, and the derivative of the cotan, which is minus cosec squared by 4. And then the answer is, the answer here, see the answer, what is the answer? 10x minus 4 cosec squared 4x. So this will be the answer. Reason because this is plus the sum, and that is one the product. So that's all. Look at this one.